So new Python 3, then you can rename that to the session NumPy. Then what I want you to do is, so first we'll import the library. And libraries are specialized commands, packages put in place to perform specialized functions depending on what the use case is. In this case, it is manipulating numerical collections, arrays, numbers, things like that. And NumPy is a library that is sort of like at the base of a lot of what the more advanced libraries for data analysis are made from. So pandas, which we are going to look at from next week, Matplotlib, Seaborn, which are visualization libraries. These are all built upon NumPy. NumPy is sort of like the foundation. And so to use a library in our analysis, we have to import it. And in this case, we do import NumPy as NP. We say as NP so that we don't have to keep typing NumPy continuously. You can leave it just import NumPy, but every time you run a command that requires a NumPy library, you have to type NumPy dot and then whatever module you're using. So to save us from typing, we just give it a nickname, so to say, and we call it NP. Run that cell. So NumPy is a library that is useful in manipulating arrays, collections, whether they're in vector format, which is one-dimensional array, or matrices, two-dimensional or more arrays. And like I said, it's the foundation of a lot of the data analysis libraries in Python. So pandas, matplotlib, they're all built on a foundation of NumPy. Once we go to those others, there are a lot of things that we'll do in them that will have been built upon NumPy. And to start us off, we'll figure out how to create these arrays in NumPy. So you remember in Python, we created lists using this command. So to now change this into a NumPy array, you have to run it through the array method of NumPy. And for that, we use, so we will call the new variable a array. And we do np.array. So this basically converts a Python list into a NumPy array. So when we run it, you see it prefaces the structure with array to show us that it's not a list, it's an array. And you can do this with any number of dimensions. So let's say this one was just a one-dimensional list. So let's say we want like a two-dimensional list, which in this case would be a matrix. So let's create a new list. And to create a two-dimensional list, this is a list of lists. So we have our outer brackets to show us that that is the main list. And then we have an additional inner bracket for each of the lists. So we have 1, 2, and our second list is going to be 3, 4. So if we run that, we'll get back a list of lists. So there are two lists, the first list 1, 2, the second list 3, 4 in a single list. To convert that into an array, same thing, b array np.array b list. And then when we call it, now you see it shows us that it is an array. It shows us in matrix form as opposed to output 5 where it showed us in list form. So here we have a matrix that is a 2 by 2 matrix. And you can get any number of dimensions you want. So C list, let's now make a 3x3, three-dimensional matrix. So this is going to be a list of lists of lists. So we have our bigger outer list, our second inner list, and then within that one, another list. So first, let's create two. So we do that, we'll get a list of lists. And then the same thing, to create it into an array, it's C array np.array C list C array. And you can go on and on as many dimensions as you want. So here we have a three-dimensional array. The first dimension, you could say, is the inner one, which is an array of one row and two items. The second dimension is this matrix of two rows, each having two items. The third dimension is now this one. So the first row, 1, 2, and then the 2x2 matrix, and then there are two of those. So you can get as many dimensions as you want. So if we run the type command on each of this, so type a list, type b list, and type c list, and then the same thing, type a array, type b array, type c array. So now I have an error type. Oh, sorry, I have missed. Yeah, here. So it shows us that all our lists return as lists, but our arrays are returned as NumPy arrays. So you can use type to find out whether your data structure is a list, a regular Python list, or a NumPy array. And then we are going to get into attributes and methods of arrays, but I want to introduce one to you right now. So you can find out the dimensions of your array using the ndim attribute. And this will return the dimensions of your arrays. In this case, array 1 is one dimensional, array 2 is two dimensional, and array 3 is three dimensional. You can also find out what the shape of your array is. So array 2, its shape, the A array is 2 by 1. So in this case, it doesn't show you the second digit, which shows you that it's just a vector. But the second one shows you that it has a second digit. So this is a 2 by 2 array. The third one is a 2 by 2 by 2 three-dimensional array. So we've seen that the first method we've used to create array is the array method. And that one, as we've just seen, so we create array np.array, and we've passed in the predefined list, but you can also pass in a list directly instead of having to define the list and then call it again. That creates your array. And you can see if we call its dimensions and its shape, we get that it's a one-dimensional array of shape 3 by 0. And you can do the same for multi-dimensional arrays. So we'll just limit it to 2 dimensions. So np.array So we have our main list, our inner list, so 1 by 2, and then our second list, 3 by 4. We call the array, and we can get its dimension and its shape. 2 dimensions, array of 2 by 2. Then beyond that, we have the arange method. So remember in Python, there's the range method, which gets you numbers over a certain range. So if you say range 5, it's going to return, let me put this in a list. It's going to return a list of 4 numbers from 0 to 4, from 0 to 3. Again, remembering that Python starts counting from 0. So arange is a method that builds on that, where you can create an array once you've specified the number of items you want in the array. And what it does, it returns evenly spaced values within a given interval. And usually the spacing is by 1 by default, or you can ask it to return a specific interval based on whatever you specify. So just to demonstrate that, so say you want an array of 10 numbers. So you're going to call np.arange10, and that returns you 0 to 9 spaced by 1. And you see, like for this one, we've not had to ask the NumPy to provide to show a list for us using the list command explicitly. It knows that when I call this method with whatever parameters I have in there, that it wants to that I want it to return an array, and so it automatically returns this for me. If I want numbers from 1 to 10, then I'll just have to do starting point, ending point, 11. So what I haven't mentioned is that whatever number you specify, it's going to return that, the last item will be that number of items minus 1. So in this case, 10, because it starts counting from 0, it's going to return from 0 to 9. So if I want from 1 to 10, then I have to specify 1, which is going to be included, to 11, but then it's going to return 11 minus 1. So 10 will be my last item. So the upper value is exclusive. So it's that upper value minus 1.
Eric, could you repeat the meaning, the definition of a range, please?
A range returns evenly spaced values within a given interval.
Okay.
If you have not specified what interval you are, you want from it, it's going to return the number of items that you have specified as the argument. So like in cell 23, I've asked it to give me back 10 values. So it's going to give me back values from 0 to 9, which are 10 values.
Okay.
Okay. If I want to specify a specific range, then I'll have to say what my starting value is and what my ending value is. And the ending and the last item will be the ending value minus 1. So say I want to get numbers from 31 to 43. So it's going to give me numbers from 31 to 42, evenly spaced by 1. I can also specify a different interval. It doesn't have to be 1. So let's say I want to get just the even numbers between 0 and 10. So 0 is my starting point. 11 is my ending point, because remember it's going to return the ending point minus 1. And then 2 is what I want it to skip. So it returns 0, 2, 4, 6, 8, 10. What if I want numbers from 0 to 24 divisible by 3? So we go from 0, 25 endpoint, specify 3, and it returns the numbers from 0 to 24 divisible by 3. A range will basically give you those numbers divisible, or rather in intervals of the integer specified. So every other number, every other third number, or every other fourth number. What if you want numbers that have an interval equally spaced between them, but not necessarily an integer interval? For that, you use the linspace method. So linspace method will return evenly spaced numbers over a specified interval. The spacing between each subsequent number is determined by the number of items specified. So by default, it's going to return, if you don't specify how many items you want to return, it's going to return 50 items. So np.linspace, say I want to start from 1 to 10. And unlike a range, it's actually going to give you the ending value. So in this case, it's going to go from 1 to 10. You'll get 10 as the ending value. If I run that, it gets me back 50 values between 1 and 10. And so it's going to divide, so it's going to look at how many items I want, and it will divide that evenly between 50. So the space between 1 and 1.1 and 1.136, you'll find that each of those is evenly distributed. To demonstrate that using different values to show you that it's actually evenly distributed, let's say you want np.linspace 1, 10, and I want it to return 2 values. So you see here, I've asked it to give me back 2 values. So it's going to return just the 1 and the 10. And the difference between that, of course, is 9. So if I was to ask for 3 values, space 1, 10, 3, it gives me back 3 values. So the space between 5.5 and 1 is 4.5. The space between 10 and 5.5 is 4.5. So it's going to get the number of items you want back, and then it's going to divide, it's going to get a division of the interval that you have specified, and it'll make sure that each subsequent number is an equal interval to as any other number in that range that you have specified. Say I want to get the numbers between 0 and 10, and I want them to be spaced by 1. So I do np.linspace 0, so 0, 10, and I want 11 numbers. So that is going to give me from 0 to 10 spaced by 1. So the difference between linspace and arange is that arange is going to get you an integer interval range of values between what you have specified as your starting and your end point. Linspace will give you an actual difference in the different values between the range that you have specified, and it's going to include the beginning value and the ending value. Any questions? So those are the 2 generic methods to generate arrays. There are some more specialized methods, and we'll look at the first one now.
Excuse me, Eric.
Yes.
Please explain again line 40.
Line 40. So line 40,
Yeah.
I want to get numbers between 0 and 10 spaced by 1.
Mm-hmm.
So my starting value is 0, my ending value is 10.
Yeah.
But because these are 11 values, then I would, if I specify 11 as a number of items I want, it's going to return the 11 values separated by 1. Between 0 to 1, 1 to 2, 2 to 3, the interval is 1. If I was to change,
Okay.
yeah, if I was to change this to a different value, it will return a different result. So that's just to show that what you specify as a third value as a number of items will specify what the interval between each of the adjacent items is going to be.
Okay.
Okay?
Okay.
We can go now to some of the specialized array creation methods. And the first one we look at is I, or identity. So you remember from matrix in mathematics that an identity matrix is one that has all values 0 except for the diagonal, which is 1s. And now this I, or identity, helps you generate that kind of matrix. And so you call np.I, and you specify the number of elements you want. In this case, I want if I ask for npi.3, it will turn a 3 by 3 matrix where the ones, where the diagonals are all 1s. I can do the same with identity. And it returns a 3 by 3 matrix where the diagonals are all 1. And you can do this for any number of dimensions of matrices. So you can, whatever number you specify in here is going to be the number of, or not dimensions, but the size of the matrix. So whether it's a 3 by 3, 5 by 5, 10 by 10, whatever number you specify here will return that size of matrix for you, where the diagonals are all 1. Then the other special class of matrices that you can generate are zeros and ones. And as the names suggest, it is a matrix filled with zeros or a matrix filled with ones. So to get one-dimensional matrix, you just call the method and you specify the number of items you want back. So let's say we want 3 zeros. Oh, sorry, it's zeros, not 0. So we get back our array of 3 zeros. And the same thing for ones. To get a multi-dimensional array of each of these, you have to pass in a tuple of the dimensions that you want. So say we want a 3 by 3 by 3 of zeros, and we get back our 3-dimensional matrix of zeros. So 3 by 3, 3 rows by 3 columns, and 3 of them. And again, same thing for ones, np.ones. This time, let's say we just want a 2 by 2. So 3 by 3. So it's going to be a 2 by 2 matrix of 3 columns and 3 rows. So here we have a 2-dimensional matrix of 3 columns and 3 rows. With this, the ones and the zeros, you can get arrays that are full of certain specific values using these arrays. So say I want an array filled with 4. So I can either do np.zeros, and I want it to be a 2 by 2 matrix. So I just add 4 to it, and I get back my 2 by 2 matrix filled with 4s. So what do you think we will have to do to replicate this, but using the ones? Anybody care to venture a guess? So we want to generate an array that is a 2 by 2 matrix filled with 4s, but you don't want to use np.zeros. We want to use np.ones. Anybody guess how we would approach that?
Eric, can I try?
Yeah, go ahead, go ahead.
Yeah, what I was saying, Eric, for me, I thought maybe you can multiply by 4.
Yes.
The ones.
Exactly. So for zeros, you do addition. For ones, you do multiplication. So multiplication by the number that you want replicated in the array. For zeros, addition by the number you want replicated in the array. So as Nicholas has said, so ones will do times 4. But you notice that when we do this operation, we get back a decimal number. So it's 4.4. What if we want to get an array that is of a certain dimension filled with a certain number, but is an integer and not a float? In this case, we use the method called, yes?
What about I'd also done, I don't know what shared the screen, but I'd also done the same, where it will be np's ones, 2 plus 3, and you'd get the same result. What about that?
Just share your screen and so that we can see what you're talking about.
So the line 46.
You've done np.1s plus 3, but it's returned 444. That's because you see you're adding 3 to the ones. And it's going to, and so it's returning 4 and not 3 as you'd expect it to. So if you add to np.1s, it's going to add the number you have specified to the ones. So if it was np1s plus 6, it would return an array of 777.
Your earlier question was if you will get the same results using
okay,
ones.
Yeah. Okay, based on that, yes. Based on that, yes. Yes, this is another way of doing it using the addition. But in my mind, I was looking the multiplication that Nicholas was talking about, which was going to be times 4. But yes, this is another way of doing it. But the most straightforward way is just multiplying it by the digit that you want.
Okay, thanks.
Okay, thank you. This will give you back floats as the values. So it's 1 point, 4 point, 4 point. But say you want an integer field array. In that case, you use the full method. So np.full. You specify the dimension of array. In this case, you want a 2 by 2. And then you want what number you want to fill it with. Let's say 5. So it returns a 2 by 2 matrix filled with 5. And likewise, you can go any number of dimensions. So 3 by 4 by 2 filled with 9s. So it returns that for me. So you use full if you want to fill your array with integer values. If you don't really mind whether it is integer values or not, you can use the np.1s and then with addition or addition or multiplication, or np.zeros with addition. Any questions?
Just repeat on the statement on line 63.
63. So line 63, I'm generating a 3-dimensional array of 3 by 4 by 2 filled with 9s. So it's going to have, so it's going to have 3 elements. Each of those elements will be a 2 by 4 array. So this is just to show you that you can use np.full to get any number of dimensional arrays filled with a specific number that you want. We've gotten our arrays filled with specific values that we have determined, but what if you want to generate arrays filled with random values so that you can test, you can run whatever tests you need using random values? So for that, we have different methods we can use. And the first method we are going to look at is rand. Rand creates an array of a given shape and populates it with random samples over a uniform distribution. And by default, it's going to generate values between 0 and 1 exclusive. So any random floating point number between 0 and 1, but 1 is not going to be included. So to demonstrate that, say np.random.rand. If I don't specify an item, an argument in the method, it's going to generate a random number between 0 and 1. And you'll see every time I run that command, it gives back a different random number. If I ask for it to generate a specific number of items, then I can just specify in there, and it will return an array of that number of items, in this case 3 items. And again, if I run it, you'll notice that the numbers are all different every single time, and they're between 0 and 1. I can specify the number of dimensions of my array. So I want an array of 2 by 2 by 2. And again, same thing. It returns 2 by 2 by 2 random numbers every single time, between 0 and 1, 1 exclusive. If I want to use this, say for example, in a computation, I'm trying to test something, you realize that, of course, if I leave it this way as an expression, then every single time I run it, it's going to give me a different value. So in order to fix it in place, I can just assign that to a variable x rand. This time let's just do 4 by 4. Run that cell. Then when I call x, x rand. So because I've assigned it to a variable, every time I run it, it's going to return the exact same set of values. So that's something to note, that if you want to generate an array of random values, but have those values consistently used, assign that to a variable, and then just call the variable after that. It's going to return to you those same exact values every single time. So I can, so like I said, this is distributed between 0 and 1 exclusive. But say I want to shift it to a different mean. I don't want the mean to be 0.5. So to do that, I can specify that I want the mean to be different. In that case, np.random.rand, let's just call 3 by 3. Let me assign this to a variable, np.rand. And say I want to shift the mean by 2. So I'll just add 2 to it. Then I call x run that, x rand. So I get, so you see now it's been shifted by, everything has been shifted by 2. It's gone from 0 to 1. The center point has now been shifted by 2. So it's now, you see here, everything was 0.0.0, but now here it is 2.7, 2.3, 2.3. So it's gone from 1 to 3 instead of from 0 to 1. So you use, and you can also do it using a negative number. So it shifts it to the left. So it's now gone from -1 to -2. So by default, remember it is between 0 and 1, but you can add a certain value to shift it either to the right or to the left, depending on what your needs are. So I can do the same if I want to shift the standard deviation instead of multiplication, of addition, we multiply the standard deviation that we want to be characteristic of our array. So let's say we want 0.3. So it's going to be times np.random.rand 3 by 3. Yes?
Excuse me, Eric.
Yes?
Can we do the addition, assuming in line 140 at the end of the end.rand. Yeah, at the end of the rand.
Yeah, you should be able to do so. So if yes, it doesn't matter whether it's at the beginning or the end, because you're just adding that value to the output of that.
Okay.
Yeah. So again, if you want to get a different standard deviation, then you just multiply the new standard deviation with whatever values you're producing. So that shifts, that alters the standard deviation of the array that you're generating. And you can combine both. You can say you want to add, you want to shift it by a certain value to the left or to the right, and you want to get a specific, to alter the standard deviation. And you get your array. So you have the option of using the straight random array as is, or you can shift it to left or right by adding the mean, or you can alter the standard deviation, or both. Again, the choice to do this depends on what it is you're trying to do, on what the data that you're looking at, what it is you're trying to do with it. The next one is rand n. And what rand n does, so rand returns a uniform distribution. Rand n returns a standard normal distribution. So the bell curve, that's what rand n returns. And again, the command to call it is the same, np.random.rand n. Without any argument, it returns just a random number, and it goes so it's around mean 0. It's centered on 0. If I specify what number of values I want it to return, it'll return that number of values. Sorry, rand n. Again, it can be any number of dimensions. So in this case, I'm doing a 2 by 2 by 3 matrix. And just like for the uniform distribution, for this normal distribution, I can shift it left or right, and I can alter the standard deviation. So use rand when you want a normal, a uniform distribution. use rand n when you want standard normal distribution. But for each of them, you actually can even explicitly call the uniform or the normal if you don't, if this confuses you and you want to be more explicit in your code. So there is the uniform method.
Excuse me, Eric.
Yes.
Just a question. Please clarify the difference between random and rand n.
So it's actually not random, it's rand and rand n.
Rand and rand n, yeah.
So rand will give you a uniform distribution between 0 and 1. Rand n will give you a standard normal distribution, the bell curve, between, I don't believe it's between, I think, negative 2 and 2. I'll check and clarify what the limits are. But so rand gives you a uniform distribution, rand n a standard normal distribution.
Okay.
Yeah. But for both of them, you can shift the mean, you can alter the standard deviation. So there's the uniform method.
Excuse me, Eric.
Yes.
I'm getting different results from yours.
You see, if you run, you see these are producing random numbers. So you're not going to get the same exact numbers as me.
Oh.
Yeah, because these are producing random. You see, the once we started with the n, the full, the I, the linspace, the A range, those ones will always return the exact same numbers so long as whatever we are specifying is the same. But for these other ones, we are producing random numbers. So you shouldn't expect to produce the same numbers as me. And even you shouldn't expect to produce the same numbers every time you run it. They'll always be different numbers.
Okay.
Yeah. So we have the uniform method. So you can specify the bounds you want the numbers to be generated from. So we say we want our low bound to be 40. We want our high bound to be 150. And you can specify the size of matrix that you want. In this case, let's do a 3 by 3. So if I run that, I get a 3 by 3 matrix of random numbers between 40 and 150. And again, every time I run this, I'm going to get different numbers. If I want the numbers to remain constant, remember I have to assign that to a variable. So that every time I call the variable, I'll consistently get the exact same numbers. Otherwise, if I run it on its own, I'll always get different numbers. So say I have my variable in my array in place. How do I get what the maximum value or the minimum value is? So there are certain methods that we can use. To get the maximum value, I use the max method. And that returns that my maximum value is 149. I'll actually type it on the same line. If I want to know the position of my maximum value, I use the x.arg max argument. So it's telling me where the maximum value is. In this case, it's in position 0. And likewise, for minimum values, x min and x arg min. X dot arg min. So my minimum value is 56.15 and it is in position 4 in the array. Any questions? Okay. Then there's also the normal method. And this generates a normal distributed array of random numbers. Again, if I don't specify a value, it'll return just one item. And again, remember, normal is between 0 and 1, unless I shift the mean and alter the standard deviation. I can specify what I want the mean is. So the first value I specify in the argument is what is going to shift the mean. The second argument will alter the standard deviation. The third argument is going to return the number of items that I want to be returned. So in this case, it has returned 5 items, mean shifted by 3.32, standard deviation altered by 0.32. And it can be a multidimensional array. So for the more dimensions, you just add that in a tuple, a bracket defined set of items, comma separated. Okay, then the next thing I want to show you is, so we've got all these numbers and they've got a certain number of decimal places. But assuming I want them to just have a specific number of decimal places. So let's assign this to a variable x. And I want the numbers to come back with a certain number of decimal places. So I use the round method. So I'd say x np.round. And then I call what I want to round off. In this case, I want to round off the values in the array x. And then the number of decimal places I want to round them off to. So it returns 2 decimal places. I can actually do the same for the full array. Instead of, I can say np.round Then I generate my array and I say return it with 3 decimal places. Then the final method we shall look at for generating random values is randint. So randint is going to generate, as the name suggests, integer values. Again, if I don't specify a value in there, it's going to just return one item. Oh, I have to specify a number. I have to specify a range where I want the number to come from. So in this case, I want it to give me a range of numbers from 1 to 10. Again, remember, 10 exclusive. So every time I run that, it returns a random integer between 1 and 10. If I increase this number, or if I specify a different range, say we want to go from 432 to 983. So it will return a random integer between 432 and 983. To specify a certain number of values to return, then I have to give in a third argument. So it returns 3 values between 1 and 10. The next thing we can look at are array methods. And the first one we shall look at is reshape. So what reshape does is that it generates a new array out of what you have specified into a different shape. So let's call a new array np.arange 30. You see we get one-dimensional array between 0 and 30, 0 to 29. But say I want to have that be in a 2-dimensional array. So in that case, I would call arr.reshape. And then I specify the dimensions I want my new array to be. So it's a 2-dimension. And so I want it to be an array of 5 rows by 6 columns. Sorry, I need to, yes. So that way I get my new array. So it has 5 rows and 6 columns. But what happens is that you noticed when I ran it that, and I called the array, if I call it, it still returns the original array. It doesn't change it in place. So for it to be changed in place, I will have to assign this to a variable so that the new variable has the dimensions of the new array. So in this case, we can just assign this to array reshaped. Then call that new array. Sorry. So now my new array is an array of 5 rows and 6 columns. One thing you need to note though is that the new array that you're trying to, the reshape that you're trying to make, the dimensions have to be multiples of the items in your array. So in this case, we have 5 rows times 6 columns gives us 30. If I was to do the same and say change that to what? To 5, it will give me an error because it'll say cannot reshape array of size 30 into shape 5 by 5. 5 by 5 will give me back 25 elements, but it is expecting 30 elements. So whatever reshape you're working with has to, the product has to be equal to the product of the rows and the columns. If it's a multi-dimensional array, so say we want to do want it to be a 3-dimensional array. So in that case, if we do 5 by 2 by 3, we'll get back our array because 5 times 2 times 3 is 30. A shortcut in the event you have your, yes.
Please explain again why we can't have the 5 by 5, why we can't reshape to the 5 by 5.
Because 5 by 5 is going to return an array of 5 rows and 5 columns, and those are 25 items. But our array is 30 items. So you always have to have an array whose rows and whose rows and columns, the product of that is equal to the number of items in the array. So our original array was an array of 30 items. So 5 rows times 6 columns gives us 30 items. But 5 rows and 5 columns gives us 25 items. And so there's a mismatch there.
So if we would have done like 6 by 5, it would have worked.
Yes, it would have worked. If you do 6 by 5, 3 by 10, 2 by 15, so long as the rows and the columns, if it's more than a 2-dimensional array, the rows and columns and additional blocks, the product is all total number of items, then it will work.
Okay, thank you.
Mm-hmm. So a shortcut in the event, say you have your array and you want to generate a different shape array, then you can specify 1 dimension. So in this case, 3, and then -1 for the other dimension, and it will automatically fill in what the other dimension is supposed to be. So in this case, I get a 3 by 10. But the dimension you specify has to be a factor of the total number of items. So if this was 7, it will return an error because 30 divided by 7 is not, will not give you or 7 is not divisible by 30. So it has to be a number that is divisible by the total number of items in the array. 15 gives me back a 15 by 2 array. And you can extend the same for multi-dimensional arrays. So arr.reshape. I want a 3. I don't know what the middle dimension is, and 5. It automatically fills in the middle dimension for me. So that's a shortcut to use. So the other method that we have already lightly touched on was the mean, the max, the arg min, and the arg max. Basically, they just give you the minimum, maximum values in your array and the position and their respective positions. So let's call our array actually reshape so that let me reshape it. Oh, reshaped. So if we want our maximum value, array reshaped dot maximum, and the position So it gives us that our maximum value is 29, and coincidentally it is in position 29. Index position. If we want the minimums, well, it's going to be that way because this is not a random array. This is an array that we specified a specific interval with specific numbers. Reshaped dot mean dot arg mean. Again, as expected, 0, position 0. But if we were to use random arrays like we saw up here earlier in this different example, in this uniform array, you saw that it's going to read through that and it's going to get the specific position within the array of what the maximum value is and its position, and minimum value is and its position. So that helps you if you're trying to analyze data and you want to know what the maximum and the minimums are and where they're located. And when we go to the practical example, you'll see a use case for that. Then now we've looked at some of the array methods. There are several others. You can go, I'll link the documentation and you can read of several others that you can play around with. Now we look at array attributes. So dimensions, which we've already touched on, and that's simply just calling oh, sorry, not dimension, dot ndim. So to get the dimensions of an array, it is the array dot ndim, number of dimensions. So in this case, our reshaped array is a 2 by 2 array, and so it's going to return us 2. Then you can do shape. And for that, it's just the name of the array dot shape. So in this case, it's an array of 5 rows and 6 columns. And you can also use these nested like with the method. So say for dimensions, I want r reshaped dot reshape to -1, 5, and then dot ndim. Because yeah, I'm reshaping this array into a 3-dimensional array, and you see it returns the number of dimensions for me. It's 3. And likewise, for shape, you can do the exact same thing. Shape. So it shows me my array is a 2 by 3 by 5 array. So these are helpful, like when you're reading in data and you want to get a feel for what it looks like before you start analyzing it. So these are some of the commands that you'll run so that you start understanding what your data is like, what it looks like, what the characteristics are, before now you proceed into the actual analysis. And then the final attribute we shall look at is the data type. And for that, you use the dtype attribute. So it shows us that for our array that we defined using the A range, the data type are integers. So it means return int 64. if we were to use rand array is equals to np dot rand 3 by 4, oh sorry, dot random dot rand, and then we query and find out what data type this is, it says that it's a float. So this gives you an idea of what kind of numbers are contained in your array, again, which might be helpful in analysis. You might be doing an analysis that expects a certain type of data, but you get a different type of data instead. So running these will give you an idea of what your data type is. And so you're not going to be, you're not going to run into unpleasant surprises when you're doing your computation later on. Now we can go to selection, indexing and selection. This is actually going to be relatively easy because a lot of it is similar to Python, but there are one or two differences that make it much better than Python. So we'll start off with the simple ones first. So let's define our array. Then we'll start with bracket indexing. So it's similar to Python. If you call the array and square brackets, and if I specify the index I want the array to return a number from, it returns that. So it's just the name, square brackets, and the index position that I want it to return something from. Similarly, I can specify something from the beginning to a certain value. So remember, if it's from the beginning, I don't specify the starting colon, the ending value, 6. It returns the first 6 items. If I want from a certain number to the end, I specify the starting value, leave out the ending value. It returns those final values for me. I can use a third argument to specify how many elements to skip. In this case, I want it to return the positive number. So I'll go from 0, so I don't specify the beginning, to the end. Actually, let me do explicitly first. So 0 to 11, and then to skip every other number. So it returns those ones for me. But remember, if I'm doing from beginning to end, I can skip the first number, skip the second number, and tell it to just bring me every other number. And again, it'll do the same thing. So the indexing and selection, so far, it's similar to Python. This is not any different from what you have with Python lists. What makes this different from NumPy arrays different from Python is that you can do a certain kind of selection that you can't do with lists. So say I want to, let me create a new list. So a list is equals to a list. So this is just a regular Python list. So say I want items in position, index position 1, index position 3, index position, the last one is what? 7. So 0, 1, 2, 3, 4, 5, is in position 6. So if I was to call out, if I was to ask it for a list of those items, so say 1, 4, 6, it'll return an error because it won't allow me to call out specific values from different index positions as a list. However, if I was to generate this into an array, so a array is np.array a list. So I have my array generated from the list. Now, if I was to repeat this same exact command, but now using the array and not the list, it returns those values for me. So that's one big difference between Python lists and NumPy arrays, is that I can ask the NumPy array to give me back specific items and not, it doesn't have to be either a slice in a range between one value and the next. It could be random values that I want from the list. And actually one good thing also is that I can call it out of order. So say I want, so start with the last item, go to the first item, get an item in the middle. Oh, sorry, this should be array, not lists. Same thing. So it's going to return the values that I specify in the order that I specify them. So you see in this second one, I've asked it for the last item first, for the first item next, and then for item index position 3, third. So how that also comes into benefit is when we go into the next thing called broadcasting. So this is when I want to change specific values in a range of an array. And this is something that you cannot do with lists. So we'll continue. Let's just create a new list. So say I want to change the values, the first 0, 1, 2, 3, 4, 5, the first 5 values into a different number, and I want that number to be the same. So, oh, sorry, I want this to be a list first. Let's make this a list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want it to be a list, not an array. So that you can see the difference. So say I want to change the first few items into a certain value. I could probably say, you remember to change a certain value in a list, you specify the index position, and then you change the value. In this case, let's put a ridiculously 999. So if I call list, the item in that position is 999. But what if I want to change a range of values at the same time? You'd think that we'd probably say a list, and I want from the beginning to the 5th item to be 999. That is going to give me an error. It won't allow me to do that. But with an array, so now let's convert this list to an array. So a array np.array a list. So for array, so just like Python, I can change a specific index position. In this case, we'll change the 999 to something else, 333. So a array, so again, it changes that to 333. But the beauty about NumPy arrays is that I can ask you to change it a certain range. So we'll do the same operation again from beginning to index position 5. I want that to be 555. So if I call array, you see, it has changed those ones to 555, something that I could not do with lists. So there's something I also want you to watch out for when we are manipulating arrays, and that's the difference between regular assignment of one array to a different variable. So say, assuming you've created an array and you don't want to work with that original array, you want to work with a copy, and then you assign it to a different variable, and then you make a change, that is going to trip you up if you're not careful. So we have our A array. Let me just change it back to 1 to 10. So say I want to perform this operation where I am changing the value of certain elements, but I don't want to change the original one. So you'd think that I'd say, so copy A array is equals to A array, copy A array. So we have the same copy here. Then I now want to change the value of these first elements in copy A array. So copy A array from the first to 5, change that to 555, copy A array. So you've seen it has changed those values for us. But if I find out what is in A array, you see, it has changed the values as well. That's because when you use the assignment operator to assign one array to another, you are simply telling the computer that this A array variable is pointing to this location in memory, and I want you to have this other name point to the same location in memory. So when you do this, you're basically, you're both of them, you'll have two different names, but they'll affect the same position in the memory of your computer. And so any change you make to one will automatically happen in the other. So like here, if I was to do A array -1 is equals to 3, 4, and then I run A array, if I run copy A array, same thing. You see it has changed that value as well. So how you prevent that from happening, you use the copy method. So the copy method explicitly instructs the computer to make a different copy of that array in a different point in memory. So let's get back our original array, 1 to 11. So if I wanted to make a change without having to affect the original array, so what I'd do is I'd say new copy is equals to A dot array dot copy. So now this is telling the computer that I want you to make this new variable should point to a completely different location in memory, that different from this one, and so that whatever operation happens in this new one does not affect this original one. So now if I was to do new copy, So you see, new copy is now 555, but my A array remains unchanged, 1, 2, 3, 4, 5. So that's something to watch out for. That if you have an array and you want to preserve the original array from any changes, make sure that you always assign the copy using the .copy method. Otherwise, you're going to change your original array. So, and a way to show a different way to illustrate that what these different methods between the copy and the regular assignment are. So we have our A array. So I'll use this same name here. So there's the is operator in Python, and is basically is used to show whether something is similar to something else. So if I was to do 1 is 1, it returned true because 1 is indeed 1. But if I was to do 1 is 2, it returned false because 1 is not 2. So if I was to do A array, or rather, let me just use the copies. Copy A array is A array, it returns true. But if I was to do new copy is A array, it returns false because these are two. New copy is different from A array. And then what I was telling you about them pointing to locations in memory. So each variable is assigned an ID when you create it, and that ID tells the program where in memory that variable is pointing to, and that uses the ID function. So if I do ID A array, it's going to return this number. So if I do ID A array and ID copy A array, the numbers are exactly the same. So I can even do ID A array is equals to ID copy A array. You see, it returns true because the numbers are exactly the same. But if I get the ID of new copy, it's a different number. The beginning parts might look the same, but then the ending parts you notice are different. And to verify that, I can just do a comparison. See, it's false. These are two different variables pointing to two different locations in memory. So this is just something for you to watch out for. When making copies of arrays, if you want to preserve the original one, always use .copy to create the new array. Otherwise, you will inadvertently be altering your original array, and you'll run into problems and not understand why. Now we can go to indexing two-dimensional arrays. So we've just dealt with the one-dimensional array. And the principles here will be the same for additional dimensions. You're just going to alter how you're indexing slightly differently. So let's create our array. Let's reshape it to a two-dimensional array. So we have our array over there. So there's two conventions of doing this. So you can call the array and then double brackets. So the first bracket can contain the row you want to get an item from. The second bracket contains the column you want it from. In this case, we want item in row 3, column 4, and that returns us 22. So row 1, 0, 1, 2, 3, 0, 1, 2, 3, and then column 4, 0, 1, 2, 3, 4, gives us the value 22. You can also do, instead of having the double brackets, you can do just a single bracket, but then now the number is separated by a comma, and this is the version that I prefer to use. Again, it returns the same thing, row 3, column 4. If you want to get just the row by itself, then you just pass in the single number and it returns for us row 3. So 18, 19, 21, 20, 23. Indexing several rows is just passing a range of the rows that you want. So oh, sorry, I used curly braces, not square brackets. So in this case, it's going to start from row 2, so 0, 1, 2, the one that starts with 12, and it's going to go to row 4 exclusive, so to row 3. So again, the last number is going to be one more than the row that is going to be returned. So in this case, it's going to go from 2 to 3. So you see it's returned 12, 13 line, and then the 18, 19 line. And same thing, if you want to go from the beginning to a certain number, you leave out the first line. Oh, sorry, change that. And then from a certain number to the end, same
Hi,
thing.
Eric.
Yes?
Could you repeat that where the second row was 18 instead of 24?
Oh, so when you're selecting a range, you remember when you're doing the one-dimensional array, it's like when you're selecting a range, you have your start value. In this case, our start value is 2. You have your stop value. In this case, our stop value is 4, but it's going to return 1 less than the stop value.
Okay.
So if you wanted the one below 18 included as well, then this would have to be 5. So it returns 1 less than the stop value. Okay. So from beginning to a certain number of rows, you can leave out the first number. From a certain number of rows to the end, you can leave out the last number. So if you want to index columns, so here we've just been indexing rows. To index columns, in fact, let me. So to index columns, so you start off again, usual, your array, square brackets, colon, comma, and then the columns that you want. So in this case, I want column 3. So it's going to return that column. So it's going to, but you see here, it's displaying, let me call the array so that we can reference it here, ARR. If you're returning just the one column, it's going to return it as a row. But you can see, if you can see the numbers, it's returned 3, 9, 15, 21, 27, 33. But if I was to ask for more than one column, so ARR colon, comma, and I want to say from the beginning to that column 3. So it's going to return them as columns. But if I use the last value as the stop value, just for, like as for the previous one, it's going to be one less than the stop value. So in this case, column 0, column 1, column 2. But it's not going to return column 3 because column 3 is index position 4. So if you're returning it, if you're returning a single column, it'll return it as it'll display it as a row, but it is indeed a column. But if you're returning more than one column, then it will show them as columns as you expect them to be. So if you want to select both, let's call our array again. So say I want row 2, row index position 1, index position 2. So that's going to be 1, 3, comma, and then I want column index position 2, index position 3. So it's going to be, my start column is going to be 2, my end column is going to be 4. So here it has returned these rows, index position 1, you can see the 8 and 9 from the second row, the 14 and 15 from the third row. And then I wanted the columns that starts with number 2. So it's going to return 8 and 14 from that third column, and the 9 and 15 from the fourth column. So that's how you get like a portion of data from your array using the indexing for the rows and the columns. The first pair of numbers will specify the rows you want returned, comma. The second pair of numbers will return the columns that you want to return from your array. The beauty of NumPy also is that you can also do some fancy indexing.
Eric, I have a question.
Yep.
You said the first bit, 1 is to 3.
Mm-hmm.
That's for the rows.
Yes, the first pair of numbers returns the rows. The second pair of numbers returns the columns.
So for the first row,
mm-hmm.
so it's going to be the one with the 8 and 9. That's okay.
Yes.
But for the second bit, 14 and 15.
Mm-hmm.
Oh, okay. I've understood. It's okay.
Yeah.
No.
You remember the stop digit is one more than the row that is going to be returned. So if we want to return 8, 9, 14, 15, we have to specify 3. If I was to do 2, it will only return the 8 and 9. So I have to do one more than I want returned. Understood?
Yeah.
Okay. So you can also do you can return the rows and the columns out of order. So say I want rows 0, 1, 2, 3, 4, 5. So row 5 followed by row 2, and then go back to row 4 and end up with row 0. So in that case, I just pass in a list of those ones. So array square brackets, and then within that, I pass in another list, so square brackets. So I want to start with row 5, go to row 2, back to row 4, end up with row 0. And it returns for me in the order that I have called them. So that's the beauty about this. So maybe there's a certain analysis you're doing and you want like a certain subset of that data in a very specific order. This allows you to return the rows in the specific order that you want. And likewise for columns. So I pass in a list of the columns that I want, but remember it's colon, comma, and then I pass in my list. So here we have 0, 1, 2, 3, 4, 5. So let's start what? At 4, go to 0, jump to 5, and let's just return those 3. So it's going to return those 3 columns. And when you're passing in a list like this, because this is not start, stop values, it's going to return the actual rows themselves that you have specified. So here we have specified 4 rows, it will return 4 rows. Here we've specified 3 columns, it will return 3 columns. From here we can go to comparison-based operators. So here it's us specifically asking for certain values, but now what if we want to get values returned based on certain tests that we've run? So let's create a huge array. We shall call it run r is equals to np.random.run int 12999, and we want 50 items. So there we have our array of random integers between 1 and 1000, and we have 50 items. So say I want to return, so array, so I want to return items in the array that are greater than 200. Okay, those ones are the ones that are more. So let me do less than 100. Oh, sorry, less than. So I want to return items in the array that are less than 100. So I call my array, my square brackets, and then within that, I have my comparison. And I want the array to go through, I want it to go through this, and anytime it sees a number that is less than 100, it's going to return it for me. In this case, we have these 3 values. But say I want to run this test consistently and I don't have to keep rewriting this test each time. I just want maybe to create a variable that does this for me. And so I just pass that as a mask into that, and it gives me back the numbers that I want. So say I can create a mask, and we can say the mask is rand array is rand array mod. So we want to get back even numbers. So if I do mask, so basically what mask does, what this does is that it returns back an array that fulfills this particular requirement. So let me actually have this on its own before we even assign it to a variable. If I was to run the test that I did up here before putting it as a mask, then I do this as less than 100. So what it does, it goes through the array, through each element, and it tests each element against this. So if an element is greater than 100, it will return false in that position. If it is less than 100, in this case, we have the truths here, here, and up here. So anytime there's an element that meets the test, it's going to return true. If it fails the test, it's going to return false. So when we use it, so now when we use this in the test over here, basically what it's saying is that go through the array, and anytime it fails or it passes this test, return only the items that pass that test. So you could either do it explicitly this way, or you could assign the test to a variable. In this case, we're calling it mask. So when I run the test, and then I just pass in mask to it, it's now going to return the values that fit according to that mask. And the good thing about it is that I can just come here and change the test. So say I want divisible by 5. Rerun that. And then if I rerun this, it returns only the numbers that are divisible by 5. So again, this is a good way. You have data you're analyzing, and we look at the sensors a bit later, and say you want just to get back the values of populations that are below a certain number. So this is a good way of getting back just those specific values. What if you have 2 tests that you want to run? So you can do that. So let's create 2 masks. So we've created we can call mask 5 for divisible by 5. So let's create a second mask, 3 divisible by 3. So round r mod 3 equals to 0. And then round. So now we want our array to return to us every value that is divisible by 5 and divisible by 3. So we'll say rand array. So we have mask 5. So here I want to do something that is going to return an error, and I'll explain why. So say, and remember, and was the operator that we used to compare two different logical operators. And rand array is mask 3. Oh, sorry, this is underscore. So you see, you get an error. It's saying the truth value of an array with more than one element is ambiguous. Use any or all. These two we are going to look at more in detail when we get into pandas. But I just wanted to show you that if you do this, you're going to run into an error. If I do, let me just get a new cell. So instead of using and again, it's the same thing with or, it'll still give me an error. Still gives me an error. So instead of using and or, use what are called bitwise logical operators. So there's another operator that you use, and that's the ampersand sign for and. So if I run that, which is my error here, runs could not be broadcast. Let me see what my error is. Let me first run this. Okay, that runs. That runs. broadcast with shapes 17 and 11. Let me just check on that. I think I know why. Let me see. Still error. Ah, I know why. Rand R mask 3 and mask 5. Yes, so even here, it's a mistake. Even before the other mistake that I pointed out, this is actually the wrong syntax. It's supposed to be yeah. So my mistake was that I was combining two. I was separating the comparisons. Here, I want one array to be returned. And so both comparisons are going to be run within the brackets, not separated as I had put them before. But this will still give me this ambiguous error issue. So if I correct my code and I run this, so you see it has run both comparisons and it has returned only the numbers that are both divisible by 3 and divisible by 5. Again, same thing I can do for OR. So for AND, you use the bitwise AND operator, which is the ampersand sign. For OR, you use the bitwise OR operator, which is the vertical. Let me see, why is it not typing it? The vertical line operator. And you see it returns all the values that are both divisible by 5 or divisible by 3. So the reason why this is the case is that for NumPy arrays, when you have the array, when you're doing the operation, it does the operation on each element of the array individually and not on the entirety of the array as a whole. And so if you're doing comparisons, when you use this AND or use this OR, it gets confused because it expects for you to compare each item individually, to run each item through the test. And so when you do this, it's looking at the entire item and getting confused since it's expecting just one item. And so the reason it asks you to do any or all, which we shall explore later, is that these two will go through each of these items and return a true or false value. But if you want to do a test where you're testing each element on its own, then you have to use the bitwise operators that I'd mentioned here, the ampersand for the AND and the vertical line for the OR. When we go into the mathematical operations shortly after this, you'll understand again the whole issue of the element-wise operation. So when you run into an error and it shows you that it's the value error and it's a truth value error, it's because you're probably using AND or OR instead of the ampersand or vertical line. If you do, again, to illustrate that point further, say I want rand R. If I was to get just one item, so index, whatever is in index position 0, and rand R, whatever is in index position 5, you see, no, sorry, I want to get comparison. Index position 0 is what, mod 2 equals 0 and rand 5 mod 2 equals 0. Sorry. Again, same mistake I had before. Just a moment. As I check this up, any questions so far? So I've gotten what I had wrong. So say I want 2 equals that. So that has to be there. Equals 0. Rand R5 mod 2. And so you see, if I ask it to just compare the one value, then this works, because here it's looking at just the one value and not the entirety of the values. And you can do the same thing for OR. So long as it's just the one value that you're comparing and not the entirety of the values, same thing. But if you're comparing all the values, you have to make sure that you use the ampersand and for comparing and the vertical line for doing the OR, because it goes through each element by each element, one by one. There's one more section on arithmetics that I want us to go through quickly before we do the final practical example. So arithmetic operations. This one will be a very quick breeze through, because we don't, doesn't have that much to it. So let's specify our array of numbers. So you remember in with Python lists, yeah, what we call array. So remember in Python lists, you remember if we did a list times 2, it just returned double the number of items in the list. And we had to use a function to actually double the numbers. The beauty of NumPy is that you can actually just say array times 2, and it automatically doubles the numbers for us. It's smart enough to know that I want you to return double the values. And what I was saying before, element-wise operation. So it goes through each element and performs the operation on each, gives you the result, goes to the next element, and on until the end. And that's the same whether you're doing array minus 3, same thing. Through each element, does the same thing. If I want to multiply, to add a number, goes through each element, adds that number to each element. Division, same thing. Goes through each element and does that. So that's the beauty about NumPy arrays, is that you can do all these operations, and you can even do array times array, and it'll return again through each element and perform whatever operation you're talking about. That's the beauty about NumPy arrays. The one question I have with arrays is that you all know the divide by 0 error. It's going to result into an error. NumPy arrays will let you do a divide by 0, but it's going to return certain results. So you need to be mindful of that. So let's create our 0 array np.zeros 5. So if I do 1 divided by 0 array, it'll give me a warning, but it'll give me an answer. Infinite, infinite, infinite. And if I was to do the same thing with a negative number, same thing, negative infinity. So negative, negative, infinite. And if I do a 0 divided by the array, it'll return not a number, NaN, NaN, NaN. So any number divided by 0 array will give you positive or negative infinity. 0 divided by 0 array will give you not a number. So that's again something to watch out for. It will not give you an error. It'll give you one of these 3 options: positive or negative infinity, or not a number. Then beyond just the regular mathematical operations that we've seen up here, there are what are called universal array functions. And we'll get more into this in future as we proceed, because some of them we might use in future computation needs. So we have our array. Say we want to get the square root. So you can do np.sqrt array. It returns the square root of our numbers. So these are functions that have already been predefined that you can just run on your array to get various mathematical operations. Say you want to do to get the log, same thing, np.log array, and you get your logarithms. So in the notes, I'm going to share a link to the documentation that has a whole list of these ones. And the use is just as simple as calling them and then calling the array as an argument to the function. And yeah, so that's it for the arithmetic operations. Okay. So now reading the file, I'm assuming your files are all in the working folder that you're working from. So they should all be visible on this folder that you have the same notebook open in. So to read in the file, so there are 3 files. Let's call the first one census codes. So to read in the file, you use a function called generate from text, gen from text. So it is np.gen from txt. Then you call in the name of the file. In this case, it is census codes.csv. Then you have to specify what the delimiter on the file is, basically what it is that is separating the different fields. In this case, it is a comma. We don't need the header. The header are the column rows, the column values. So like the name, the sub-county, population, all that, we don't need that. So we ask it to skip header equals 1. So it's going to skip the first row. And then when you look at that data, it has a column for county and a column for sub-county, but we are not working with text data. We're only using numerical data. So we need to tell NumPy which column specifically to bring in. In this case, we say, so use calls and we pass in a tuple of the columns that we want. In this case, we want columns 0 and 2. So I'll just copy paste this for each of the other files that we're reading in, change just 1 or 2 items depending on what columns you want to use. In this case, we want to do 2, 3, 4. We change the file name to ph. We change this to ph. Then the third file is going to be using columns 1 and 2. Skip header is 1. This is AD, AD, AD. Okay, so we have our data ready. Then now we can find out, we can look at the data and see what they look like. So census codes. Let's just look at the first 11 rows. Sorry, top 10 rows. So to get up to the 10th row, we can leave out the beginning value and we go to 11. So to us to get the first 10 rows. So we run that, we get the values. So census codes, that file is just has the codes and of the counties and the sub-counties. So 1 is code for Mombasa, 101, 102 are the sub-counties in Mombasa, 204 is it Kwale or Kilifi, whichever comes next, 201 the sub-counties, and on and on. We've read in our data. We are looking at what the top 10 rows in each of the columns are. Census PH, so PH, so this is the population and households data is in the census PH. So it's population, households, and average household size. And then the final data set we're looking at is the census AD. Again, let's look at the first 10 rows. So census AD contains the area of each sub-county and the population density in those sub-counties. So now that we have seen what our first rows are, and again, we can look at the shapes of each of our arrays and the dimensions. So it shows us that our codes is two-dimensional. It has 334 rows in 2 columns. Codes, the area density it's two-dimensional. It has 334 rows in 2 columns. The population and housing, two-dimensional. It has got 334 rows in 3 columns. So again, this gives you an idea of what it looks like, and then knowing what the raw data looks like, this makes sense. So there are 334 sub-counties listed. So these, I extracted this from the census report from last year. And it shows that there are 334 sub-counties. So at a glance, it shows you that, okay, this data is okay. But now we have them in 3 different tables, and analyzing them might be a problem if you have to keep shifting back and forth between each of these 3 tables. So the best thing would be to combine all of them into 1 table, and then we just work with 1 table going forward. And there are different methods in NumPy that you can use to combine different types of tables. There's the H-stack method, which combines tables horizontally. There's the V-stack method, which combines tables vertically. In this case, we are going to use the H-stack method because we are just adding different columns together to form one table that has all the columns listed together. So we are combining the different tables into one table. We'll call the overall table census. We're using the hstack method because we want to combine them horizontally. We pass into hstack a tuple of the different files, starting with the file that we want to be the leftmost. In this case, it is census codes. Then we want the next to be census population and housing. And we want the final to be census area and density. Then if I call the top 10, I now have my tables all in one table. And to verify that that is indeed the case, I can get the number of dimensions. It's going to be 2, and the shape. See, 2-dimensional, 334 rows with 7 columns. 2 plus 2 plus 3, 7 columns. So this shows that we've read in the table successfully, and it doesn't have any unexpected errors. So we have our table that has the 334 rows and the 7 columns. This is just going to show us what the different rows are. Oh, sorry, this is supposed to be markup. Okay. So this is a reference. So like I said, so the country code is column 0, sub-county code column 1, population, households, average household size, area, density. So let's now do some aggregations. So say we want to find out what the sum is. Sum is one of the universal array functions that you can see in the documentation that I'll share. But if I run that, you notice it returns one number. That doesn't make sense. Basically, what it does is that it's going to sum every single number in that array. And that is a meaningless number. So I want to get just the sum of the columns themselves and not the total column, total sum of all the values. So I do census.sum axis is equals to 0. And so now it returns the sum of each of the columns. So the sum, the first two don't make sense because it is just of the code and the sub-county code, but the rest should sort of make sense because this sum of the total, the population, some of the households in the country, average household again might not make sense. Area does make sense because that's the total area of the country. Density might not make sense. So we can clean that even some more so that we just get the sums of the columns that would make sense. In this case, we want the sum of the total population, total households, and total area. So to do that, this is now where the selection that we were doing before comes in handy. We want to select only these 3 columns. We want to select all the rows, and so we don't specify the start or the finish, comma. And then now we put in a list of the columns that we want. So we want column index position 2, index position 3, and is the index position 5. So it's only going to return the aggregates that we want from these specific columns. And we want to do .sum axis is equals to 0. And now we have the totals in just those 3 specific columns. So the total population, the total number of households, and the total area of the country. Now you see some of the theory that we learned before is beginning to have actual use, real world use. So now what if we want to get what the totals of each county is? Here we've got the totals of the full country, but we just want totals of each county. To do that, first of all, let's figure out how do we select what county we are interested in. Again, Boolean selection. So we have our table sensors, the empty brackets, sorry, that's not what I meant to do. Yes. So sensors, so we put in our empty brackets in there, but we want to get just the, so we are creating this comparison, which is going to return to us only those items where the county code is 1. So you see here, we've said sensors, we want the first column, and we want for that column to return only the values where it's equals to 1. In each case, county code 1 is Mombasa. So it returns to us this array that has the trues in the Mombasa rows and false everywhere else. So to go a step further, so now we've made our mask, and actually I can give this, yeah, let me just leave it that way. So we've made our mask. So now let's get back the actual values from that column. So sensors, and we want to pass in sensors, the first column, where the first column is equals to 1. If we run that, we now get back only the rows from that first column. And each of those rows is a sub-county in Mombasa. If I was to extend this further, if I wanted to get just the one row where the sub-county is 101, then I'd run that command and it will return just the one row in Mombasa whose sub-county code is 101. So you can use this to get whatever information you want from your table using just these comparison operators. But let's go back to the original one of, we want all the sub-counties in Mombasa. So we have our rows of our sub-counties in Mombasa. So now, how from this, how do we select just the first, the population column? You want to study a bit more in depth the numbers of population. So we've selected our rows. This returns all the rows in Mombasa, but we want just the population column. So we have our filter on here, and then now we add an additional square bracket. We want it to return all the rows of that column, and we want to return it only the column index position 2, which is population. So the first part returns all the rows of the county we want. The second part returns the specific column of just that one county, of that one county. And if we run that, so now these are the population numbers in the Mombasa column. And if I open, let me open the, where do I have this? So you see here, you can, if you look at the numbers, the population is 135, 41, 162, 287, 249, 147, and 213. And you see they match these numbers, 130, 162, 287, 249, 147, 213. So we've been able to extract the population numbers in Mombasa County. And then now to get the sum, of course, we just now call the sum method. But you see here, because, let me do, but you notice here, I don't call the axis because there's only one on only one column that I'm doing the aggregate on, and so I don't need to specify the axis. If I run that, I get the totals of the population in Mombasa County. So we've gone from reading in the table to getting data of numbers in one county to getting numbers of population in that one county and getting the totals of that population. So we've seen how to do that for one county, but now we want to get it for all counties. How do we do that? So we can use a while loop. So for the while loop, remember that it tests a certain value. And if that value is true, it performs the computation. When the value becomes false, it stops the computation. So let's have a counter, let's call it I. Let's set it to 1. 1 being the code for Mombasa. Let's define a new list, empty list. Let's call it population. So we want to test that while I is less than or equal to 47, and 47, why? We have 47 counties. And so it's going to go through each of those county codes, and each time it experiences the same county code, it will do the computation. Once it's done with, then we're going to increment the county code, and it's going to test again. If it's less than 47, it will go again into the loop, perform the computation again. But we are doing less than or equal to 47 because if we just did less than 47, it's going to go until county code 46. To make sure that 47 is captured, it has to be less than or equal to. The last time it will increment to 48, come back and rerun the test. 48 is greater than 47 and still stop the test. So while I is less than or equal to 47, population.append, and then this code that we use to get the sum in Mombasa, we'll just use that same code on here. But then instead of comparing it to 1, we compare it to I, our counting variable. Then remember you have to increment your I, otherwise your code is going to run forever. And then we can call our population and we get our population totals. Then remember that we can also use list comprehensions to do the same thing. So we can say population is equals to, by the way, this up here, we've generated a list. If I was to do type population, it will show us that it is a list. But we can have it as an array as well. So for the list comprehensions, we'll actually just create an array. So np array, then now we create our list comprehension. We have a square bracket. We want it to return we want it to do the calculation and populate a list in that. So we say sensors. We do our test of what we want from that sensors. We want the first column so that you can get the county codes. If that is equals to the county code that we need, get the third column, which is population. And then sum that. Let me make sure my brackets are in order. 1, 2, 3. 1, 2, 3. That is that. Yes, so get the population column, sum that. And then we want to do that for all i's in range 1 to 48. So it's going to go through, it's going to generate these numbers from 1 to 47. Remember, 48 is exclusive, so it's going to stop once it reaches 47. Then if we call population, I have something, population. So we have our population as an array. Again, we have the totals in place. So we have that, but then now we want to sort the numbers so that we can get maybe what the top 10 populated areas are. For that, we use the sort method. Remember, it sorts in place. So we need to call population to actually see the sorting performed. And we have, so it has sorted our array from the least populated to the most populated. But what if we want to look at the most populated? We want to reverse the order of this listing. So remember the command we had to sort a list from front to back. So we leave out the starting option, I mean the starting value, because we want all values. We leave out the start, the start and the stop, and then we do -1. So if we run that, we find that it has now sorted our array from the most to the least. However, the issue with this is that if I leave it as is, and then I call population again, you'll see that it did not preserve our sorting order. And so we have to save that into a variable. So top, ascending, sorry, descending pop. So that way, if I call the variable, it has now sorted it for me from the highest to the least. And then to get the top 10, it's just a matter of top 10 is equals descending pop. So remember, we start from the beginning, we go to the item number 10, but we have to call in 11 so that you can get the top 10. And then if I run that, I get now the top 10 populations. What if we want to calculate the average household size per county? So we can say average is equals to, we will just use a list comprehension straight away, np.array. So sensors, we want the first column to get our county codes, compare that to the index so that it counts through the county codes. This time, average household size is column index position 5. So that's what we are going to get. And then we want to get the means. And it's for I in range 148. So if we call that avhs, so we get our averages on there. Say you want to run an actual extra verification. So let's use Nairobi as an example. So let's say of NBI. So let's get the values for Nairobi. Sensors is 47, 5 of NBI. So these are the values that we have from Nairobi. And let's manually calculate the average and make sure that it matches this figure of 63.97, which is the last item on there. So for that, first let us sum the values. AV dot sum. We get our value 703. And then NBI average is equals to, so our sum AV NBI dot sum divided by len AV NBI. And remember, len gives you the length of your list. So here we are looking for the length of the items in Nairobi. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 items. And then we call AV NBI average returns 63.9277, which is the same calculation we got up here, 63.97277. So this shows that our code is running as we expect it to. And assuming you have numbers, the numbers are too big to test, actually to make sure that we have the very same exact values that we need, we can say AV Nairobi average, and then we want to test that to AV, what did we call our AVAHS? That's the total AVAHS. We want to test it to the last item, and you can see it returns true. Again, further confirmation that our calculations are correct. This begins to show you some of the data analysis work that can be performed. And you'll appreciate pandas a whole lot more, because here you've noticed that we've had to remember what each of the columns are. We've had to reference the columns using the indexing and slicing notation as opposed to actual column names. So next week when we tackle pandas, you'll appreciate its capabilities even more, because it does what we've done today, but in a much easier way. We don't have to write as confusing code to get things done as we've had to do with NumPy.